between them. The range doesn't distinguish between them. But are these the same? Are they distributed the same? No. So measure of center and range don't consider distribution. But isn't distribution really important? Didn't we just figure that out? Yeah. All right, so let's do this. All right. Thankfully, I've got a handout, so it's not going to just be me talking all damn day. Okay. Let's do this one. Let's see. We write like this: 1, 5, 5, 5, 9. And we know the mean, so the sum of x was 25, right? So the mean was 5. Okay. Is that cool? We already did that. Okay, I like it. Everybody with me? Let me say again what I want the spread to mean. The average distance from each data point, the mean. Now, real quick, just go. Everybody, that's a really good note to take, because I'm going to ask you that on the test sometime in the future. What does the standard deviation tell? What does the spread thing tell you? The average distance from the mean to each data point. That's what it means. So let me say it one more time. The average distance from the mean to all the data points. So how do I calculate the average anything? If I want to know the average shoe size in here, what do I have to first get? A list of
shoe sizes.
And then I can average it. If I want to know the average number of years you've been driving, what would I have to first get? A list of years that everybody was driving. You with me?
Yeah.
So if I want to know the average distance from the mean to the data points, I have to first get a list of distances from the mean to each data point. Does that make sense?
Yeah.
To find the average blank, I need a list of blanks so I can average them, right? And is everybody with me? That spread, that makes sense? Spread should be how far away from the center you get on average. And that's why 5, 5, 5, 5, 5 had no spread. Didn't get away from home. They all stayed home. Whereas these two, which one of these two is going to have a larger spread? Why the second one is more than kids got the hell away from home, right? Yes.
Is the spread like the standard?
Yes, standard deviation.
Okay.
That's the official technical name.
Okay.
I'm going to try to bring that in a minute. I want everybody to keep remembering that it basically means spread. So I'm going to make a list of what we just said. If I want to find the average distance from the mean to the data points, I got to make a list of distances. So distance, of course, is subtraction. Is that cool?
Mm-hmm.
So what do you get for each thing? The mean is 5. What's 1 minus 5? -4. And then 5 minus 5, 5 minus 5, 5 minus 5. And then 9 minus 5 is 4. Okay. You guys with me? Mm-hmm. This is a little bit like watching sausage get made. We're constructing a formula. That's what we're doing. And you guys have never really gotten a chance to do that. Now, obviously, I'm guiding you because it's all been done before. I just want you to catch up with it. But I want you to buy into every step to realize why it makes sense. There are other ways we could have gone with this. But this is the way that makes the most general sense. Here's a place that we could have done. Now watch. How do I find the average? I have to do what with these? Add them all up. But what do you get when you add them all up?
0.
You always will get 0 here. There will be equal amounts negative as there are positive, always. That's what the mean does. Right? Maybe?
Yeah.
So thanks, Jeff. What the shit? Thanks, man. You got us to a point where it's always 0. Accolades. All right. So obviously, we can't stop there. One option to make these not add up to 0 is to take the absolute value of all these. You with me?
Yeah.
All right. I'm not going to get too deep into this. Some of you guys are like, dude, you're in. All right. Does anyone know? Do you guys understand that? In fact, absolute value means distance. So it kind of makes sense we would use it here. There's a whole lot of reasons we don't. And we actually use it, but not a lot. It's called standard error. You don't see it very often. But does anyone know what a standard, what a absolute value looks like? If you draft it?
Oh yeah, it's just the V.
Because a lot of you guys know what x squared looks like.
It's
right? So parabola, right? But absolute, if you graph it, what's the absolute value of 1?
1.
Holy shit. What's the absolute value of negative 1?
1.
And what's the absolute value of 0?
0.
So it's this V, right? You guys with me? Is that a plane that you want to be in?
No.
All right, everybody. Everything's going really well. I'm glad you're flying here. You're all dead. You're all slammed up. That is a crazy ass turn. In mathematics, we hate that. That kind of turn is called a kink. Right? Kind of makes sense. It's a kink in a hose or something. What's the slope here? Negative 1. And then right there, it suddenly instantly becomes 1. So in a plane, that acceleration would be infinite. You'd all die. Plane would crash. It would be crazy. You guys with me? So, like I just said, so instead of doing an absolute value of this shit, we have to, and there's a lot of math behind what I just talked about. But that's the deepest I want to go into that. So the better option is the one that makes that turn nicer. What I want to be in this plane, hey everybody, how you doing? Oh, we're fine. Just make a little turn, right? Plane kind of banks and you're like, oh, okay. Instead of that plane is like, boom, and you're all dead. Maybe?
Yeah.
What does squaring stuff also do? It makes it come out positive. So that's another alternative. Now, if I square all this shit right now, at the very end, I'm going to have to undo that. So I'm going to have to take a square root. Does that make sense? If these are dogs that people own, when I square them, they are now square dogs. But this is what is that? Oh, it looks like Fluffy fell in the trash compactor. No, we don't want that. Oh, that's why I like it. Too bad. I love dogs. Don't get, I don't compact them. Don't worry. Save space. So I'm going to square these to kill the negative. I have the option of using the absolute value, but there are several reasons we don't.
Okay.
So what do you get when you square each one of these?
Same thing, but.
Well, no. Negative 4 squared is 16.
0, 0.
So what I'm going to do right now, the kind of compromise we had to make is I'm going to find an average squared distance, but what am I going to do at the end? Take a square root. So why did I have to square right there? Because otherwise they had to be 0, and the spread is always 0 for everything forever. That's not useful. Okay, I like it maybe. So what do you get when you add these up? The sum of x minus the mean squared, 32. Okay. Why did we do that? Because we're trying to find the what distance? The average distance, right? So what would I do next? I added up those. So next thing I have to do is, how do I find the average? Add them up, and then you add them all up, and then you do, right? By how many there?
Yeah.
So I'm going to officially call this, here's the letter for it, the lowercase sigma. Looks like an R that got really fat. So when I write them, sometimes they're skinnier, they're fatter. Those are all sigma, lowercase sigma. It's got a little square on it to remind me that I haven't taken a square root. So this is called the variance. Why am I using a Greek letter? Because these were populations. Okay. So how do I find the average square distance? I add up the distances squared and divide by how many there are. Do you see how this is just an averaging equation? Add up these divided by how many there are. That's the average these. Bam! So what did we get for this whole thing? This is where some of you guys have got to realize, do I know what x is? What is x equal to? All this shit at once.
Yeah.
So you can't plug something in here. I know what this whole damn thing is. What's that whole damn thing? 30 frickin' 2. That's what's different. We don't put values in for letters all the time. We sometimes replace whole things with numbers because that whole thing means the sum of these, and I sum them up. So in that place, I'm going to put 32. And then what's n? 5. 6.4. Okay. So what do I still need to do to really get what I really want? Square rooted, right? Careful, it's not pointing. Don't get too excited.
2.6.
Go for, yeah, keep going. 2.6.
Well, I rounded 2.5. 2.529.
2.529.
Yeah. Or 5.3.
No. Come on, just keep going.
The whole thing?
I'll tell you when to stop.
Okay. 2.52982212.
Okay, stop. All right. So we're always going to round standard deviation to at least 3 decimal places. So I would take this. Now here's a little tricky one. What would this be if I wanted to round it to 3 places?
2.5.
Good.
3. Yeah.
If you wanted to, you can call it 2.5298 because that's at least 3 places. You can round it to 4 if you want to. Just don't frickin' take it out to 12 or something, right? You guys look so excited. So what that number means is on average, every data point gets 2.5 steps away, 2.5 away from the middle. I like it. So if we did this one, would our answer be bigger or smaller than 2.530?
The second one?
If we did the second one,
It
yeah,
would be higher.
it would be bigger, right?
Bigger.
Because it's got a bigger spread. We said that a while ago. Okay, so here's my handout for you. So what I've done for you on this handout, and by the way, if you have to leave early, I got the practice test I'm going to give you guys, so you might want to grab it. One side of this is a completely worked out problem with all the kind of questions I like to ask on these kind of problems. And this side is a blank one for you to do. Okay. I'm gonna, before you start doing stuff, I want to show you how to do a lot of this in the calculator. We're gonna kind of recapture the first side of this in the calculator so you can see how it works. You got some coming. It's coming this way. Stay. Okay. Let's see. Oh, yeah, you're there. Okay, what's kind of nice, on the, let's start on the side that's worked out. Once all done, I try to put on this sheet I always forget this. Oh, Jeff, I love it. All right, before we do this, I want to explain one thing. What we just did was an example of a population, right? Mm-hmm. So there is a slight adjustment if the poor little thing is just a sample, which is what I gave you on the sheet. Go with me for a minute here. All right. I'm gonna try to explain this. One thing that's gonna change is if it's a sample, you're not gonna see mu, you're gonna see x bar. You're not gonna see sigma, you're gonna see s. And why do we use the letter s for this? Because it's standard deviation. Makes sense. You with me?
Yeah.
And then here's the ultimate thing that's gonna change. Let me see if you guys get this. There's an average age in here right now, right? Of course there is. You with me? I wish somebody would have come in the door right then. Oh, let's just change. If I took a row at random, like let's say this row, right? Would these guys' average age be closer? me try to say, with these guys' ages, each of these guys' ages, would they be closer to the average age of everybody or closer to the average age of them? Them. Does that make sense? Because that's who they are. Their average age, their ages will be closer to the average of all these guys. You with me? You with me? Make sense? So if I'm going to calculate the spread, the standard deviation for a sample, it is always going to be smaller than it should be because it's going to be closer to its own mean instead of everybody's mean. If you get what I just said first, you have to get what I just said now. If I calculate their spread and I use the exact same formula we just did, it's always going to underestimate it because they are closer. What spread measure? How close something is to their average. They are closer to their own average than they are to everybody. Average, right? So what we do is to find the spread for a sample. I know it's a sample because I got our letter here, not a Greek letter. First off, the top is going to look a little bit different because it's got to have an X bar instead of a mu. And then I'm going to divide by something that makes the answer bigger because remember what I just said? They're going to underestimate it because they're closer to their own average. So really, in reality, it should be a little bigger. So instead of dividing by n, I divide by something smaller to make the whole thing bigger. I divide by n minus 1.
Just 1.
Yep.
Okay.
And this, believe it or not, is something we talked about earlier. Let me see if I can do this real quick. By the way, the way to look at this is just an adjustment because it's a poor little sample. That's really why we do this. Okay? So remember the thing about if I have 3 numbers that average to be 10? We did this before. How many of them can I just totally make up and not even care? But then when do I have to start getting serious to make the average come out to be 10? So if they average to be 10, what do they add to be? We did this whole thing before. If 3 numbers average to be 10, what do they have to add to be? How do you get an average of 10 from 3 things? You add them all up and divide by 3. What do you divide by 3 to get 10? 30. So they all have to add to be 30 in order to average to be 10. So I can just go crazy on the first 2. I don't give a shit. Somebody give me a number. 18. Somebody give me another. Somebody else. 16. But now I got to get serious. Because all together they're supposed to add to be 30, right? What do these add to be already?
34.
So how do I make it become 30? I got to make this guy become. So how much freedom did I have in this? If I have 3 numbers that I have to deal with, how much freedom do I have? N minus 1. So this is actually something that's going to come back later this semester again. It's called degrees of freedom. Sorry. Think about Braveheart. You can take away. Sorry. Can't take away my degrees of freedom. All right. N minus 1 is called the degrees of freedom, which that name makes sense because it's sort of like a measure of how much freedom you got to go crazy. It's the last dude you got to be serious to make it come out to the right average. If you have no idea what the hell I just talked about, this is a standard deviation for a, well, it's a variance for a sample. Little different because it's just a sample. It's just, that's the adjustment because it's just a poor sample. Okay, so now let's look at this sheet. Holy sheet. Bless you. Oh, where'd you go? Here. So, oh my gosh, that's so bright. So here's the worked out side, right? So I did the average. In fact, isn't that the other? Yeah, that's so funny. I didn't do this on purpose. This is really cool. That's the other set of data, right? 1, 2, 5, 8, 9?
Yeah. Oh, that's right.
Right? Okay. So up here, I showed you the calculator commands to redo this. So let's try this out. For small sets of data, you could do each row by hand. But my God, I'd much rather have this stupid, crazy, expensive thing do it all for me. So everybody, remember how to get into your lists?
Mm-hmm.
What do you hit to get into the list?
Stat.
Stat.
Edit.
Edit. All right. So everybody get there. If you got stuff in any lists and you want to kill it, just go up to it and hit clear, enter. Don't hit delete, because then it'll delete your list. It's like, all right, I'll do what you want. I still have some calculators if anybody needs to borrow one. Okay. Some of us are like, well, I'll just watch you for now. So let's try to put this in here. So 1, 2, 5, 8, 9. Everybody put that data in there. I want the next list. So let me go up, hit up, so you got the L2. I can control the whole list now. So if you've ever used Excel, this should feel a little bit similar, but unfortunately, it's not as powerful as Excel. Go up to L2, and now I can control the whole damn list. What I want the next list to be, X minus the mean. Where are my X's at? L1. So I want it to be L1 minus the mean, and the mean in this case happens to be 5. So if I tell the calculator, oh yeah, L2 is L1 minus 5, I'll get all that shit. Right? Let me know.
Yeah, can you do that again?
Sure. Let me show you what I'm doing. So go up to L2, because I'm controlling a whole list,
So L2 is C.
and then hit L1,
Oh,
L1 minus
minus
5.
Got it.
Bam. So that if you've used Excel, that feels familiar. You can control the whole column. If you've never used Excel, you're fine. Do that. Okay. What do I want L3 to be, of course?
L2 squared.
L2 squared. I want to square the shit I just did, right?
Mm-hmm.
So go over to L3. Hit L2 square, your square. And then you get those numbers that I got on the sheet. All right, now here's the next thing. What do I have to do with L3 next? I have to add it all up, right? I got to add this up. Let's see how I got 50. Now, of course, this is a relatively small set of data, but here's how to do it in the calculator. Everybody hit second mode to quit. Get the hell out of the list. Now hit second stat. See how that's list up there? I can do shit with my lists now.
Yeah.
And then what do I want to do with list 3? I want to add it, don't I? Isn't that a mathematical idea? All right, go to math. Let me know if I've passed you by. Everybody with me on this?
No.
Let me do it again. So, let me come back out. So get to this screen, get out of your list, then hit second stat so I can go into my lists. And this is where I can do stuff to each list. Go over to math because I want to sum up list 3. Don't forget the lists are right above the number keys, right? There's list 3 up there, above 3. So make sure it says sum L3, and I'll get my 50.
Yeah.
Okay. All right, I'm tired of hearing myself talk, so go ahead and try out the other side. And if some of this don't make sense, you can call me over, but don't forget, this side is worked out. What's up? You need a calculator?